Greeting and welcome to lecture number 12 on unit number 5, part 2, external flow. This session we are going to discuss a drag and lift forces. Generally, this is applicable for submerged object. In various engineering fields, we encountered with the problems which involve the flow of fluid around a submerged bodies or object. In such problems, either a fluid may be flowing around a stationary submerged body, or a body may be flowing through a large mass of stationary fluid, or both the body and fluid may be in motion. Some of the examples are motion of very small objects, oblique bodies such as fine sand particles in an air or water, or a very large bodies such as aeroplane, submarine, automobile, uh, ships, etc., moving through air or water. So these are the object which experiences drag or lift force. Generally, ground vehicles they experiences only drag force, and the flying objects like the parachute or aircraft or any other flying objects, these objects experiences drag lift force as well. Up to certain extent, these object experiences a lift force, but the dominant force is the inertia force or drag force. So this object experiences the force. So all these objects require some power to drive, and they mainly the air offers resistance to the motion of these objects. So it is always recommended to, or it is always to have a lower of these resistances. And how to minimize these resistances? There are various aerodynamic theory developed for that. So accordingly, the body makes streamline like this. Suppose this particular body experiences a larger amount of drag force compared to this particular body, or this body we can call is also a streamlined body. So this experiences a less drag force as compared to this. There are some structures also experiences, especially large, tall buildings or bridges experiences a drag force due to the wind. So under these circumstances, also the drag and lift forces are obtained. So these are some practical applications where the drag force or lift force are calculated. Now, whenever there is a relative motion between a real fluid and a body, the fluid exerts a force on the body, and the body exerts a equal and opposite force on the fluid as well. And if the body is moving at a constant velocity in a stationary fluid, the fluid motion is unsteady because at the point in a space where the velocity changes with time. However, if the body is stationary and the fluid flows at a constant velocity, it's a steady motion. But the magnitude of the forces in both cases, or this is the case one or case two, is same uh, because both there is a equal and opposite force when the body as well as fluid. Uh, a body wholly submerged in a real fluid may be subjected to the following two kinds of forces due to relative motion between the body and the fluid. And these are uh, drag force, which is the component of force in the direction of the flow or free stream on the submerged body, and the lift force, which is the component of force perpendicular to the direction of flow. Uh, this the drag force is denoted by Fd, lift force is denoted by Fn. When the free stream approaches the body along the axis of symmetry, the force acting on the body is only the drag force. Suppose these two cases, when the free stream approaches the symmetric body, so symmetric body experiences only a drag because the forces acting equal and opposite on both sides from top and from bottom. So there is no possibility of lift, like this case, or this case. The force always, the only drag force in the direction of flow. There is no lift force generates here. The production of lift force requires a symmetry. So like the same object, if we make it inclined, then this particular flow's passage is asymmetric, because if we see this is a diverging portion, this is a converging portion. So the asymmetric portion is there. So in this particular case, lift force is generated. Drag force exists always. It is possible to create a drag force without lift, but it is impossible to create lift force without a drag force. So whenever there is a drag force is generated, lift force has to be there, but not in case of drag force. Only drag force is present without any lift force. So that is the for symmetric objects. For asymmetric object, the lift is generated, but it is always associated with the drag force as well. Now the expressions for this drag and lift force, if we see any arbitrary body which is held stationary in a stream of real fluid, and the velocity of this free stream is capital U. The fluid density is rho, its viscosity is mu, because it is a real fluid. Now, on an element dA on the surface of the body, let P, small p, and tau represent the static pressure and shear stress. These are the forces acting here on elemental area dA. Let theta be the inclination of the tangent to the element with the direction of flow. So the shear force acts tangentially, and the angle of tangent is theta with respect to the direction of motion. The component of the force due to P and tau along the direction of motion is known as a drag force. Suppose if we see PdA, it has two components: vertical component perpendicular to the direction of flow, and horizontal component PdA sine theta. So these are the two components of PdA. Similarly, this is a free body diagram actually. So similarly, so this portion is experiences shear stress tangentially. This component has again two components. This particular resultant force, that is shear force, has two components: horizontal and vertical component. Tau dA cos theta and tau dA sin theta. It makes angle theta with the direction of motion. So the component, horizontal components, so as per the definition of drag force, the component along the direction of flow, they are called as the drag forces. So these two are the drag forces, and the components perpendicular to the direction of flow, so these two are the lift forces. So considering in the figure, we can write the total drag force, that is equal to integral PdA sine theta. So for the entire surface, we can calculate. So this is for elementary. For entire surface, we do the area integral. Integral PdA sine theta plus integral tau dA cos theta. So these are the two components of the drag forces. And the component of lift forces, that is tau dA sine theta and minus PdA cos theta. Because vertical component, the components perpendicular direction of flow, they are called as the lift forces. So if we integrate it with respect to, so because integral symbol represents the integral over the entire body of the surface. So this is surface integral. So after integration, we get the expression of FD and FE. Then the resultant force is calculated, that is F, that is equal to under root FD plus FL. FD square plus FL square. Uh, this component PDA, that is called as a pressure drag. The component PDA sine theta. So there are two components of drag. So this component is called as a pressure drag or form drag, or we can say tau dA cos theta is called as a friction drag. That is because drag has two components. It is called as a friction or skin drag or shear drag. So these are the expressions of FD and FL. But after integration, the contribution of shear stresses to the lift may be neglected since shear stresses are small as compared to the pressure and acts in the direction roughly perpendicular to FL. So for body moving through a fluid of mass density rho at uniform velocity u, the mathematical expressions for calculation of drag and lift may be written as Fd is equal to CdA 1/2 rho u square and FL is equal to CLA 1/2 rho u square. So these are the expressions used generally for calculation of drag and lift forces. The earlier expressions are that is applied for any arbitrary object, but whose area is not known. In that case, we need to integrate that. But if the fixed areas are there, then we uh, generally use these expressions. Drag force. So where CD is the coefficient of drag, CL is coefficient of lift, both are dimensionless. So don't get confused between these CD values with the CD value in flow over a flat surface. There the CD value is the frictional drag and this is for the form drag. These are the components for the form drag. This is obviously a component for the, this is a form drag. Rho is the density of the fluid, U is the relative velocity of the fluid with respect to body. A is some characteristic. Actually, the A is considered the projected area of the object on the normal plane. So for calculating the drag FD, usually the area A is taken as the area projected on the plane perpendicular to relative motion of the fluid. For calculating the lift force FL, the area A is taken as projected area of the body on a plane at right angle to the direction of lift force. So this way the areas are considered. Now, in the case of aerofoil, the projection is conventionally taken as the plane of the chord, that is the area of the wing itself, independent of its inclination to the direction of. So the area of chord, the chord into length, that chord length into length, that is considered length of the wing, that is considered as a area for aerofoil section. There are some examples of emerged bodies having drag and lift forces. A tall chimney exposed to the wind. Already we have quoted the diagrammatic examples, but these are some examples which experiences the drag and lift force. Tall chimney exposed to the wind. Flow of water past a bridge. So both cases drag forces experiences. Flow of fluid past blades in fan. Blowers, compressor, and turbine. So because of the drag force, actually the power is generated. Motion of aeroplane, submarine, torpedoes, etc. Examples of bodies with these are the bodies. They are experiences drag and or lift force, not both. Generally, where both forces are present, they are propeller blades, aerofoil. Their experiences both drag and lift. Hydrophiles, rotating cylinder bodies, kites. Then following points are worth noting in case of drag and lift. In contrast to drag, lift forces may exist even in ideal fluids. by the presence of circulation, but drag force is not present in ideal fluid. Real fluids also require vorticities or circulation around the body for producing lift. And in motion of airfoils with fine spans, there is another kind of drag force associated with the lift force, and that drag force is called as a induced drag. So that is associated with the lift. That's it from this particular session. At the end of this session, you will be able to discuss or define what is drag or lift forces. You will be able to explain different components of drag and lift forces with the help of the integral expressions. And also, you will be able to quote some examples or practical applications where drag and uh, lift forces are present. Or we can easily segregate the applications also where the pure drag or pure lift forces are generated. That's it from this particular session. Thank you very much.